National 5 Maths, Practice Paper I, Paper 2, Question 12. Now in this question we were given a right angled triangle, we've got some measurements in terms of x, and we've got to calculate the value of x. Well, it's a right angled triangle, so we can use Pythagorean Theorem and say that x squared plus x plus 7 all squared equals x plus 8 all squared. So it's not entirely obvious to some people that you would need to use Pythagoras, but you do. So when we multiply out these brackets, you get x squared plus 14x plus 49 equals x squared plus 16x plus 64. So I've got lots of x terms on each side, so what I'm going to do is I'm going to take away x squared from both the sides to start off with. So that gives me x squared plus 14x plus 49 equals 16x plus 64. I'm going to subtract 16x from both sides. So x squared take away 2x plus 49 equals 64. Subtract the 49 from both sides. Sorry, subtract 64 from both sides rather. So it's going to be x squared minus 2x minus 15 equals 0. Now that we've got a trinomial there equal to 0, we can factorise it and get a couple of values for x, and we can pick the appropriate one. So if you factorise this, we're looking for numbers that multiply to make negative 15 and add to make negative 2. So multiplying to make negative 15, you can have 3 and negative 5, or negative 3 and positive 5. It works here with negative 5 and positive 3. So something times something makes 0. For this bracket to be 0, x would have to be equal to 5. So we would say x equals 5. For this bracket to be 0, x would be negative 3. Now, it's a length, and you can't have that measurement there being negative 3. That doesn't make any sense. So it has to be 5. So therefore, we can score that one out, and we can say that x equals 5 centimetres. Now, in question 13, we've got to find the height of the building. We've got a couple of triangles here. We can use some sine rule and some trigonometry, well, that's trigonometries and sine rule, some basic SOHCAHTOA, as you probably refer to it as, and we can find out what the measurement of AD is. Now, we can start off looking at some of the angles that we've got here and fill in some of the missing ones. Well, in this triangle here, they all add up to 180. So if I do 180, subtract the 90 for the right angle there, subtract 55, that gives me an angle of 35 degrees. Okay, so we've got that. Then if you look at this larger overall triangle, I've got 90, I've got 38. So again, if I do 180 minus 90 minus the 38 degrees, that's going to give me 52 degrees. Now 52, that's not that little one, that's this entire angle here. That's 52. So to find the smaller one, we do 52 take away 35, and you get the little one in there. So 52 take 35 is 17. So we get that. Now, if we look at this triangle here, we can use the sine rule because we've got a pair of sides and angles. We've got an angle and a side there. There's a pair. Now we're going to find this measurement here. Then we're going to use that measurement again with SOHCAHTOA to find out what this vertical distance is. So I'm going to try and find this side here, and I've got my pair with that angle there. So I've got D, B, and C. So rather than A over sine A, B over sine B, etc., I'm going to use D, B, and C. So B over sine B equals C over sine C equals D over sine D. Well, B is the length there. Angle B is this one here. We don't have either of those, so that's no use to us. Don't need that. So it's C over sine C. Well, we don't know what this measurement here C is, so we can just leave that as a C over sine 38 equals D. That's your measurement of 5 over sine 17. Now, if we cross multiply those, you get C sine 17 equals 5 sine 38. Divide both sides by the sine 17. And that comes to, got it written here somewhere, 10.5 meters. Okay, so we can fill that in the diagram here. So 10.5 10.5 meters right there. Okay. Now, we're going to look at this triangle here now. I'm going to use the 55, I'm going to use my 10.5, and I'm going to find this measurement here. So I'm going to label them up opposite adjacent hypotenuse. So there's my angle. The angle next to it is the adjacent, across from it is the opposite, and the 10.5 meters is the hypotenuse. So I'll write down SOHCAHTOA and score off what I know and what I want to know. So here I've got, I don't have my adjacent, so I've no interest in the adjacent. I've got my hypotenuse, and the one that I want to find is the opposite, that's the height of the building. So I'm going to use the sine ratio. So SOH, and it's the opposite I'm trying to find. So the opposite is sine of the angle, which is 55, times by the hypotenuse, which is 10.5. So sine 55 times 10.5 gives us a height of 8.6 meters.